Hello students, I am here with another video from the chapter of class 10th NCERT book, that is periodic classification of elements. Before starting today's video, I would like to tell you all that till now what all things we have discussed in this chapter. So we have started this chapter by the word that is classification. Now what does this word classification means? This classification means that whenever we are grouping something on the basis of particular similarities and the differences, okay. So we have seen that there were different number of elements, and at the present time 118 elements are discovered, okay. So when the 118 elements were discovered, so it was really very difficult for the scientists to understand and to read about each and every characteristic of the elements, okay. So what they did, it was like means they were trying to identify, they were trying to classify according, they were trying to make it in a group, okay. Now what has happened? So one of such scientists called whose name was Dauvergne has tried doing this work for the first time, and his law, or you should say that classification, was known to be as Dauvergne triads, okay. So what is this Dauvergne triads? Dauvergne triads means when we are taking, see, this Dauvergne has, what he has done, he has taken the group, he has made his periodic table on the basis of the increasing order of their atomic masses, okay. Now once these atomic masses are being placed in order, we can find that there is certain pattern being followed. Now what was the pattern which was identified by this person, by Dauvergne? So he has he saw that when we are taking the three elements, then we can easily recognize the pattern, and the pattern was that when we are taking three elements, then what has happened, for suppose that this is the triad, and where we can check the atomic mass of this number first and the third. So the average atomic mass of first and the third number was equal to was approximately equal to the atomic mass of the second element, okay. So this was the triad, fine. So this was the triad. Now what has been done, this was very clear from the the findings that the triads were easily being recognized because they were, so this triad was like when we have to add the atomic masses of the first and the third element, it was approximately equal to the atomic mass of the second element, okay. So this was about the triad. Now next scientist, whose name was Newland, he has also found one law, and the name of the law was the Newland law of octaves, okay. Now what was that Newland law of octaves? It said it was it means the second, now the scientists have got a way to discover this, or to design one classification, or to design the periodic table, okay. Now what was the classification being done? So this was the second classification which was being done by the Newland law, by the Newland, okay, and he made a law of octaves. And what does this octave said? It meant that whenever we are arranging the elements in the increasing order of their atomic masses, it also again forms a pattern. Now what pattern did he recognize? He recognized that the first and the eighth element has got to be the same characteristics in the periodic table, okay. So the characteristics of the first and the eighth element matched, it was matching in the chemical as well as the physical properties, okay. So this was a Newland law of octaves, and he also has connected his classification with the notes of music, okay. Then after that, the third classification was of Mendeleev. Now what did this scientist said? This scientist had told that whenever we are again arranging the elements in the form of their increasing order of their atomic masses, then we can again see the pattern which is present in this classification, okay. So in his table, he has again taken up the same concept of this atomic masses. Then what has happened? Again he followed one pattern. Now what was that pattern? He also has taken up the physical as well as the chemical properties into the consideration. Now, because of which the things were very much simplified. Then if his table was divided into two groups, one where the elements were chemically combining with oxygen, and the second was whenever the element were combining with hydrogen to form hydrides and with oxygen to form oxides. Now, once these oxides and hydrides were also being found out, then what has he done? He has made one classification, and even his classification and his periodic table was also followed till long time. After that, the latest form of the periodic table has come, and that is the latest form, or the most acceptable form, or that is the long form of periodic table, or we could say that this is a long form of periodic table, or it is the modern periodic table. Okay, it is modern periodic table. Okay, children, what does this mean? What is the meaning of this modern periodic table? So, this modern periodic table means that it was followed. This is one of the most acceptable form. Okay. Acceptable form of periodic table. Okay. Now, why this was the most acceptable form of the periodic table? The very first thing was that it was based upon atomic number. Okay, so we have discussed all the features of this periodic table, where it was being classified into the two ways, by using the two words that were the groups, and there are 18 groups, and how many 18 groups are there, and 7 periods are there. Okay. Now, this 18 group is known to be as the horizontal, this 18 groups are the vertical columns, and these 7 periods are the horizontal rows in this periodic table. Fine. Now, I am going to draw this periodic table. Okay, so in the yesterday's class, I have discussed about the trends as well as the so the trends were also being taught. So, what does this trend mean? So, we have seen that there is a particular pattern which is being followed by the components of the periodic table, such as the valency also follows a trend, the atomic number follows a trend, it is the atomic size also follows a trend if we are moving down the group or we are moving left to right in a period. Okay, so we have seen all these trends very much in details. Okay, after that we have also solved some questions. Now I am going to continue the numerical part of this chapter today, and that would be the last part of this chapter. And because I think this numerical part should also be discussed with you all, as I have discussed in my previous videos also, where after completing the chapter I have discussed about the number of numericals for each and every lesson which is there in your NCERT book. Okay, so here in this classification or this periodic classification, it's very important to know how to solve the numerical and what kind of numerical it will come. Okay, in the examination. So, from examination point of view, I have taken up some examples of the modern periodic table. Before that, I must draw a modern periodic. Yesterday I have drawn this modern periodic table. Okay, now what is that? Now today I have drawn one periodic table again, but it is not on the board, it is on the sheet of paper. As you could see here, this is a modern periodic table. I think it might be visible to you all or not. Okay, I'll put up here. So this is the periodic table which is being drawn over this, and this was same which I have drawn it yesterday. Okay, so you could see here. Fine. So this is the periodic table, and this is also given in your NCERT book, and I'll just quickly redraw this, and I'll just tell you how to fill this table in a very easy manner. Okay, so what is this about? You will draw the first, the second and the third period. Okay, I'll draw a small one, so it will be easy for you all to understand. Till here it will be a 12, so this is here and the next is here. Fine. So here this one is first, second, third group. Okay, from here till here this is 12th, from here 13th, 14th, 13, 14, 15, 14, 15, 16, 17 and one more 18 has to be drawn, 18th. So this is 18th group. Okay, 13th, 14th, 15th, 16th, 17th and 18th. So I'll rub this off. I'll make it again. 13th, 14th group, then this is 15th, 16th, then after that it is 17, this is 16th, 17th and 18th. Okay, so this one is 18th group. Fine. Now what you will do, you will simply fine, you will make this 1, 2, second period, third, fourth, fifth, sixth and seventh period. Okay, fine. And now third, fourth, fifth, sixth and seventh. Now this is the periodic table which I have drawn here. It's not very much visible, that is why I have drawn this here. Okay, so this I have discussed yesterday also. Now I just wanted to tell how to solve the numerical which is based upon this periodic table and how will you fill the number of elements by finding the number of period and the number of the group. Okay, now what you have to do, you have to find out the most important thing for this chapter, for this finding out the numerical would be, the first thing is that you have to find out the group number and the period number, the group number and the period number. Okay, so the next thing what you have to follow, what you have to find out is the period number. Okay, कैसे अब निकलेगा ये? Let us see this. Okay, so what would be the answer? How would you find out? How will you find out by using the simple formula? As I have told you, the group number, it means that the number of valence electrons. Okay, now what is the period number? It means that we'll count the number of shells. Okay, so this is very much easy to understand now. You have to simply count the number of valence electrons, and period number means it is the number of shells. So fine. After that, what you will do, you will just simply do one thing, that you are going to find out. You are going to find out how we are going to place the elements in this periodic table. We are going to give the number. Fine. Now how we will do that? This thing will be easily being done because of doing the calculation. Now please understand that if the valence electrons are 1, if the valence electron is 1 or 2, if 1 or 2 valence electron is there, so if it has 1 valence electrons, it means it is in first group. If 2 valence electrons are there, it is in second group. Okay, now if more than 3, if 3 or more electrons are present, then what will happen? You will just add up 10 plus the valence electrons. Okay, 10 plus valence electron. Please remember this, 10 plus valence electron. Suppose that if it is belonging to 13th group, what would happen? It is going to be 10 plus 3. It means it becomes 13 because it has 3 valence electrons. Because it was having 3 valence electrons, that is why we added 10 in the number. Okay, so this is very easy to this is very easy for us to make up. Now you can solve the numericals very quickly and with this trick. Okay, now what would you do? We will solve this by using the first question, or for this everybody should know about the electronic configuration and the atomic number of each and every at least till 20 elements everybody should know. Okay, so I have given you homework also, that you have to complete the table which has a symbol, which has the atomic number, also which has it should have the electronic configuration as well as the atomic structure. Fine. So we have already done this. Now after this, what is expected from you? You should all learn all these things. At least from 1 to 20 means from hydrogen till calcium, everybody should know the atomic number. There is no need to learn the mass number. If you learn, it's well and good. Otherwise, there is in 10th class, there is it's not very much necessary to learn the atomic mass right now, but you should learn it very frequently, so that it would be helpful for solving the other numericals in the other chapters. Right. Now I come back to this topic, how to assign the place in this modern periodic table and how we will do that. Okay, so with this here, from why I have left this 13 to 12, why this? Because here this is the transition element, these are the transition element. Okay, I'll change the color. So this is the transition element. Fine. And this is the 0 group, and this is the group for the here the group is there, and this is known as the period number. Fine. Now what would you do? How will you find out the how will you assign the elements in this periodic table? Fine. So this was being told yesterday only, that you have to learn about the atomic number. So where you have to understand that how to just represent this atomic number with a symbol. For example, if this hydrogen is for example lithium is there, so how would this lithium going to be represented? So this is Li, its symbol is Li, and then it is going to be represented, the atomic number would be represented by writing the atomic number just below this symbol. Okay. So next thing, what you would see, that how would you place this lithium in the periodic table? Now the next question is, how would you place this lithium in the periodic table? Fine children, now how would you place it? I'll just simply write down the way by which you could place this lithium in this periodic table. Fine. So we'll just write down lithium, whose symbol is Li and its atomic number is 3. Fine. Now with the atomic number 3, what would be its electronic configuration? K, L and M. We will write down like this. So if it is 3, then in the first shell it is having 1 electron. Now in the second shell, how many electrons? It could first shell it would be 2 electrons. Okay, because this is the K shell, and the maximum number of electrons in the K shell could be only 2 in number. And then what about the next one? That is 1. 2 plus 1, 3. Now we are left only with the 1 electron. So in the next shell we will have the 1 electron. Now this last shell is said to be as the valence shell. It means it has how many number of shells? Number of shells is equal to the number of horizontal row, that is said to be as the number of period. So here how many shells are completely? 1 and 2. 2 shells are there, it means it is going to be in the second period. And what about the group number? That group number means the number of valence electrons. So the number of valence electrons is equal to 1. Okay, so it means it is going to belong to, that is equal to the number of group. Fine. So what would be the number of group? That would be 1. Let us now see how this valence electrons, and how would you decide the group number or the period number here? So we would easily find out that this belongs to period number second. First, second, and the number of valence electron is 1. It means lithium would be placed here. This is the second period and the first group. It means its place is here. So lithium would be placed over this. So if you have to place the lithium, where would you place? You are going to place this lithium in this periodic table where you are going to place? You are going to place it here. Where? In the place of lithium would be here, and the second, okay. So this is the second period, and the first group, lithium with the atomic number 3. So that would be the answer, lithium with atomic number 3. Okay. Now next thing what we will discuss, we have assigned this first. Okay. Now what would be the next? For hydrogen also, that would be easy for you all to understand how to find out the number of where it would be placed, and as it is very easy, I am not going to take it. The next thing is that if you are going to take up boron, okay. For example, boron has to be taken. Now what is the atomic number of boron? Boron's atomic number is 5. Okay, I think that would not be very much clear. I will rub it off. So now we will take up the next example, that is boron. Now with this boron, whose symbol is B and its atomic number is 5, its configuration would be K and L. So 2 here in K shell. Now how many left? 3. 2, 3. So how many number of shells? 2 number of valence. It is in the second period. And what about the group? Number of shells are there, 2 in number, so it is in the second period. What about the group? In the third group. Why? Because it is having 3 valence electrons. So it is coming in the second period, and group number 3, second period and group number 3. Okay. This is coming, okay, here 1, 2 and 3. Now the next thing is that if I said whenever the valence electrons are 3 or more, then what is the concept? 3 or more. Whenever we are having 3 or more valence electrons, it is going to be written by the formula 10 plus valence electrons. So what are the valence electrons? The number of valence electrons are 3. It means 10 plus 3 is equal to 13th group. So it is not going to be in the third group, it will be in the 13th group. It will be placed somewhere here, second group and 13th group and the second period. That is, it is going to be here. Boron's place is here in the 13th group. Okay. Now with this I will solve the next question. So the next question would be for nitrogen. Okay, nitrogen, it has a symbol of N with how much atomic number? The atomic number of hydrogen, so this nitrogen is how much? This is 7. Now you are going to configure it, K and L, 2 and how much? 5. It becomes 7, 2 and 5, 2 plus in the K shell and 5 in the L shell. Now how can you decide the period number? It will be decided by the number of shells. It has 2, so its period number is 2. And what about group number? Now group number would be, it is 3 more than 3 electrons, it means 10 plus 5, it means in the 15th group. Fine. So in the 15th group and the second period, 15th group and the second period. So you will write nitrogen here, just match it with your periodic table which is given in your book, whether it is right or wrong. So you are going to place, you are going to make this type of periodic table, and you could easily fill. Now you can fill the nitrogen as well as the whichever example we are going to take, you can fill this. So I will just fill it for you all. So where you are going to place the nitrogen, this boron we have filled. So we are going to fill this boron here in the 13th group. So boron will be filled here, as well as nitrogen is filled in the 15th group. So I am going to fill it here as nitrogen. This would be nitrogen. Okay. So this might be clear, or you could see like this. So I have filled boron here, and next is the nitrogen. Okay. So the next question, now I am going to solve this, and simultaneously I am going to fill this also, and that would be very easy to understand. And I think the concept might be clear for you all, that how to find the group and the period number, and how to assign the position to any of the element. Now the next question we would solve about the next, that is, okay, if one more question is there which is in the form of the numerical part, and that is which of the outermost shell, now which outermost shells are present if the element belongs to second period. So if the element belongs to second period, it means how many number of shells might be there. So the number of shells would be how much if it is belonging to the, if it is having it is present in the second period. If it is present in the second period, it means that how many shells are having? It will be having 2 shells in it. Okay, as we are counting that that period number is decided upon the number of shells, which is 2 in number, which means that it is having, it would be present, it would be having the 2 shells if any element belongs to the second period. Okay, so these types of question could also come. Now the next question is that if an element, okay, we'll place some more elements and then afterwards we'll solve this. The next question, that would also be the numerical part. So the next would be, I'll solve for potassium. Okay, for potassium we will solve. Potassium symbol is K and whose atomic number is 19, and how would you configure it? You are going to configure it as KLM shells. For K shell you will fill 2 electrons because it can maximum occupy the 2 electrons. Then after that 8 plus 2 10, 8 18, then how much? 1 is left. KLM and N shells are there. After having the N shell, you will write down 2 8 10 plus 8 18 plus 1 19. So here in the last shell only 1 electron is left. It means that it would be belonging to which period? Period number 1, 2, 3rd. No, the period number would be the, what would be the period number? That would be what would be the group number? That would be very easy for you all to understand, and we will start with the group number. So group number would be, group means it is the number of valence electrons, it is 1, group 1. And what is the period number? As it is having the one group in the valence shell, it is also belong, and how many number of shells are there? 1, 2, 3 and 4. So it is going to belong, it is going to be present in the, so as it is having one valency and the group number also says it is the number of valence electrons, so it is 1, so it belongs to group first in this first column. Okay, now what about period? It is 1, 2, 3, 4, it is number of shells. So how many number of shells are there? Number of shells are 4. So in the 4th period, this is 4th period and first group. So the answer would be here. Okay, potassium would be placed here in the 4th period and the first group. Fine. Now the next thing, next question we will solve. Again, I think now it would be easy for you all. Okay, now we will solve some more, that is about calcium. Okay, we will take up calcium, which has the symbol of Ca and it has 20 atomic number. Then what would be the number? How would you write down the atomic configuration, electronic configuration for this? That electronic configuration could be K, L, M and N, that is 2, 8, 10, 8, 18 and 2. 2, 8, 8 and 2. Now how many, what would be the group number? Group number, that is equal to the number of valence electrons. Okay, so that is equal to the valence electrons. How many valence electrons are there? 2 valence electrons are there, so it is going to belong to the which group? It is going to belong to second group. Second group. Why? Because it has 2 valence electrons, that is equal to valence electrons. Fine. Now the period number is equal to 1, 2, 3, 4, that is equal to the number of shells. So please count the number of shells. 1, 2, 3 and 4th shell are 4 shell are there. So it means it is going to belong to the period number 4th here and the group number 2nd. It means it is going to belong, it is going to be placed over here. This is calcium. Okay, so this is calcium. Fine. After that, after placing calcium at 20 number, We can even count also, you can even count also. Okay, now next we will find out one more example. We will again fill the next, that is for, I'll fill some more tough examples so that it would be easy for you all to understand now. And the last example I take up is of helium. Okay, I'll take up for helium. Helium has 2 atomic number. Okay, it has 2 as its atomic number. Now please tell me, it has its electronic configuration would be 2. Now how many valence electrons? 0 valence electrons. So group number, it has 2 electrons, but you cannot place it here in the second period. No, because it is having 1 shell. It could not be placed here. The place of this group would be 0. Why? Because there is no valence electrons, please remember. So this helium is having the completely filled duplet because it is having the K shell, and that K shell, it is having only 1 shell, and that too it is completely filled. So this is having the 0 group. So that will be written somewhere here. Okay. Now what about the period number? Period number first. So this is the period number first, and this belongs to 0 group. So the right answer for helium, right place for the helium would be here, 0 group, first element. Fine. Why? Because its valency is 0 and number of valence electrons are 0. Okay, fine. Now next we'll take up the neon. Similarly, we'll take up neon. So now this neon has atomic number of 10. So how would you fill this? 2 K and L shell, 2 and 8. This again, this is 8 completely filled electrons are there. So which group? Group number 0. Why? Because this is having the 8 electron in the valence shell, and that is the maximum electrons which could be occupied in the L shell. This is completely filled. So it belongs to 0 group. So that would be the 0 group. Now next is that which period it is going to belong? Number of shells, if you count 1 and 2. Number of shells, that is the period number second. So period number second, and the position of the neon is this. Okay. Similarly, you could calculate for argon also, krypton also. Okay, you could calculate it very easily. Fine. So what would be the answer for this? Next would be, if you can take out for argon, argon also. Okay, so that would not be visible. So I'll just quickly take out the last part, last question. That is again an inert gas. That is about argon. Its atomic number is what? Its atomic number is 18. So please write down, and then K, L and M. 2, 8, 10 plus 8, 18. So again it is a completely filled electron. So which group? It belongs to 0 group. Okay, why? Because it is having the 0 electrons, valence electrons. Next, what would be the period number? The period number would be 1, 2 and 3 by counting the number of shells. So it belongs to third shell, third period. Now next, here the answer would be here. Okay, so this is how you can fill the 0 group elements also. So children, that's all for today's video. I have told you how to fill the electrons in the valence shell, how to fill this periodic table on the basis of the group number and the period number. Now you could decide it very easily, and that's all for today's video. Even this chapter is also completed. Now I'm going to start with a new chapter in the next video, children. That's all for today's video. I will meet you all in the next video with the next topics to be discussed, and I hope this chapter might be very clear to you all, and you could ask your doubts in your online class and complete your notes, complete the numerical part as well, and please submit your copies, submit the images of your copies in my email. Okay, so that's all for today's video. I'll meet you all in the next video with the next topic to be discussed.